Now once the information has been input, we can now start working with that information. Firstly, today we're going to look at half adders. Now half adders are used whenever we want to add two single bits together. Now the way that it works, if you guys think back to grade 10, we're looking at the binary addition, whereby if we take 0 plus 0 we get 0, 0 plus 1 is 1, 1 plus 0 also 1, but if we've got 1 plus 1 we've got 0 and then we carry 1 over. Now if we put this into a truth table and the carry over, let's label those zeros. If we've got 0, 0, 0, 1, 1, 0, 1, 1 and we add them together, we will see that we get an exclusive OR for the sum because it's looking for an uneven number of ones. The carry over is only affected when we get two ones on the input. As a result, that'll be 1 and those will be 0. So we can see the sum column is an exclusive gate and the carry column is an AND gate. As a result, in order to construct this using normal ICs, we will work as follow. There's A input, there's the B input. Just to get back to that, consider this. The top row of bits, that'll be my A inputs. Bottom row would be my B inputs. And then the carry over bits would be the top, the C over there. Now firstly, looking at these, this will be my sum output, and we see the sum output looks at the inputs and exclusive ORs that value. Okay, both inputs are connected to that one. Next we've got our carry over, and the carry over comes from the B input as well as the A input, and that'll be an AND gate. Now when it comes to full adders, that's when we're adding multiple strings or strings with multiple bits together. Now when we're looking at those, full adder, okay. So the full adder works as follows. We are now adding multiple numbers. For example, let's say 1, 0 plus 1, 1. That'll be my A. That'll be my B. My carry will be on top there. But now, that'll be my first adder, where there's no carry over from the previous step. And that'll be my first one. So looking at the half adder, we will see we've got A and B. A and B gives me a sum total, and it gives me a carry total. That is my half adder. Now for the full adder, it's going to come from the carry over from the previous, and that's going to be added to my bits. So typically these two will be added with a half adder, and then all the consecutive ones after that will be added by a full adder. Now the full adder is a bit more complex, and you're welcome to go do the Boolean logic behind that yourselves. But we've got A, B, C, we've got our sum total, and we've got our carry from the previous adder. So just to make this simple, let's call those all ones, but the carry comes from the previous step, so that is those numbers minus 1. So quickly drawing out this truth table, when looking at this, we see from the half adder that the sum column is looking for an uneven number of ones. Okay, and the carryover looks for 2 or more ones. So there's 2, there's 2, there's 2, and then there's 2, like that. Now looking at a combination circuit for this, we've got A and B. Let's call those N's because we don't know which adder this is, but these two feed into a half adder, and then we've got the carryover from the previous step, so we're calling it carry N minus 1. This half adder adds to the carryover from the previous, and this will give me my sum for the N, and then this half adder's output from the carryover and this half adder's carryover together goes into an OR gate, and that will give me my carry over from the previous step, Cn. Okay. Now if we want to break this up further, we can say Cn minus 1, A n Bn, A and B both goes into an exclusive, and they also go into an AND. That's the carryover, and that is the summing. Okay, so those two go in like that. Okay, my summing there is going to go into an exclusive OR and another AND. That's my second half adder over there. That one's fed in from there, and from there that one feeds in there and feeds in there, and together that will be my summing output. These two must then feed into an OR gate, which will then be my carry output. The symbol for this one is very basic, very simple. A and B are my inputs as well as my C, but that's from the previous step, and those are from the current step. These three feed into my full adder, and then on the output I will have my carry and I will have my summing outputs. Now, as a simple application, let's look at how we're going to combine these in order to form a adder in total. Okay, so we always start with the least significant bit on the right and the most significant bit on the left. So firstly we're going to feed this into a half adder. Half adder is going to give me a sum. That's my zeros, and my carryover is going to feed into a full adder. A, B, ones, this is my sum 1, and my carry for the first full adder. This feeds into a second full adder, A, 2, B2, that's going to feed into my summing, that's going to feed into my carry, which is going to go to my next full adder, A3, B3, that's going to give me my summing, and that's going to give me my carry over. Now, as an example, let's say we want to take the following bits, 1011 plus 1001. We want to add those two together. The top bit I'm going to use as my A. I'm going to put that in green. Brown I'm going to put as B. And all my carry values, let's put that in orange. Carries are going to be at the top. Now just to simplify this column is my 0 column, that is my number 1 column, that's my number 2 column, that's my number 3 column. Okay, so we've got green for the A's. Most significant bit over there is a 1, then that's a 0, then there we've got a 1, and there we've got a 1. Then brown is my B's. Most significant bit is a 1, then a 0, then a 0, and then a 1 over there. We do not know yet what the carries are going to be. I'm going to do my sum. No, not in orange. I want to do my sum in black. So that's my summing. Now looking at this, 1 plus 1 is 0, carry 1. That 1 we're going to carry over there. So that is going to be carry 1. 1 plus 1 is 0, carry 1. Now we've got 1 plus 1, that is equal to 0, and we are going to carry another 1 up to the top there. 1 plus 0 plus 0, sorry, that's a 0. 1 plus 0 plus 0 is 1. Let's check. 1 input, that's a 1. And my carry over is going to be a 0. So then we go 1 plus 1 is 0. Plus 0 is still 0. And then we're going to carry the 1 over there. So looking at that, 1 plus 1 plus the carry from the previous, which is a 0, is equal to 0. And then the carry from there is going to give me that over there. And that is how we generate a 4-bit binary adder with an example of how it operates.